This is Azfar Asad and you are watching the Saaz Academy's YouTube channel. Chapter number 2, The Particulate Nature of Matter. Subchapter number 2.1, Kinetic Particle Theory. Matter. Anything that has mass and occupies space is known as matter. There are three forms of matter: solids, liquids, and gas. Solids, they have fixed volume, fixed shape, incompressible, do not flow. Liquids, fixed volume, no fixed shape, but takes the shape of container, incompressible, flow easily. Gases, no fixed volume, no fixed shape, compressible, flow in all direction. The kinetic particle theory of matter. Particles are too small to be seen directly. There are spaces between particles of matter. The amount of space varies between each state. The particles are constantly moved. Each state moves in different speed. Diffusion. Diffusion is the spreading and mixing of particles in gases and liquids. Diffusion of gases. Bromine drops are placed into a jar. Another jar full of air is placed on top of jar with bromine, separated with cover. Cover is removed and bromine evaporates, filling both jars with dense reddish-brown bromine vapor. Explanation. Bromine particles move from lower jar into spaces between air particles in upper jar. At the same time, air particles move down from upper jar to mix with bromine particles in lower jar. Eventually, bromine and air particles are mixed completely. Diffusion of liquids. CuSO4 crystals placed in beaker of water. Blue particles of the crystals are spread throughout the water to form uniformly blue solution. Factors affecting rate of diffusion. Number 1, temperature. The higher the temperature, the more particles of matter absorb energy, making them move faster. The highest will be the rate of diffusion. The lower the temperature, the slower the rate of diffusion. Mass of particles. Greater mass, the slower it diffuses. Smaller mass, the faster it diffuses. A cotton soaked in aqueous ammonia and another soaked in hydrochloric acid are placed on opposite sides of the tube. NH4OH vapor and HCl vapor diffuses in the tube and a compound is produced inside the tube closer to HCl soaked cotton as the particles are heavier. The greater mass, the slower particles diffuse. The smaller mass, the faster particles diffuse. Particulate models of matter. Particles in solid. Number 1 are packed close together in orderly arrangement. Number 2 have little empty spaces between them. Number 3 can vibrate but cannot move freely about their fixed position. Particles in liquid. Number 1 are packed closely but not orderly arranged. Number 2 have little empty spaces between them but more than in solids. Number 3 are not held fixed but free to move throughout liquid. Particles in gas. Number 1 are far apart and in random arrangement. Number 2 are free to move anywhere in the container. Differences between properties of matter and particles in them. Number 1. Matter can be colored. Example, sulfur is yellow, but particles are not. Number 2. Substances feels hot, cold, but particles don't get hot, cold. The temperature is due to speed of movement in particles. If hot, particles move fast. Number 3. Matter expands when heated, but particles don't. Changes of states. Number 1. Melting. Melting is change from solid to liquid, but absorbing heat to break force of attraction holding particles together. The temperature at which solid melts is melting point. From the graph, point A to B, the temperature of solid increases to melting point. From point B to C, the temperature remains constant as heat is absorbed to break forces of attraction instead for raising temperature. Solid and liquid are present. Point C to D, liquid heats as heat energy increases temperature. Number 2, freezing. Freezing is the change of liquid to solid by cooling down of liquid. Freezing point is the temperature at which liquid freezes. From the graph, point A to B, liquid temperature decreases to freezing point. From point B to C, heat energy is released as particles slow down to take up fixed and orderly position of a solid. The temperature remains constant. Release of energy compensates for loss of heat to surroundings. From point C to D, solid cools to the temperature of surroundings. Number 3, boiling. Boiling is the change of liquid to gas by absorbing heat to break the forces holding them together. Boiling point is the temperature at which liquid boils. From the graph, point A to B, liquid temperature rises to boiling point. From point B to C, heat energy is absorbed by particles to break the attractive forces so that they move freely and far apart as gas particles. That's why the temperature remains constant. Number 4, evaporation. Evaporation is change of liquid to gas without boiling. Occurs below boiling point on water surface. It gives cooling effect, heat energy absorbed from surroundings. Number 5, condensation. Condensation is the change of gas to liquid. Heat energy is given out as gas particles slow down and move closer to one another to form liquid. Number 6, sublimation. It is the change of solid to gas without melting. Heat is absorbed. Please like, subscribe and click the bell icon to get the latest updates and live stream notification from the Saaz Academy. Thank you very much.